Suppose omega f p a probability space and xn are random variables which are L1 integrable and xn are also independent. And expectation of xn is 0 for all n. Now construct a new random variable zn. The sum of xn show that Zn is a martingale. Now since x1 x2 xn are fn measurable, and suppose this sigma algebra is generated by this x1 x2 up to xn, this is something called natural filtration. So clearly Zn, which is sum of all this xi up to n, is also fn measurable. That is, we can say this fn adapted. Why? Because sum of a measurable function is again a measurable function, right? Now the second property, since each x1 each xi is in L1 omega fp, so this means E of modulus of xi is finite. Now Zn is sum of xi I from 1 to n, so this means modulus of Zn is modulus of this whole sum from 1 to xi, which is less equal to sum of the modulus from the triangle inequality I from 1 to n. So this means expectation of modulus of Zn is less equal to expectation of each xi, which is also finite. Now the last, we haven't used yet the independence of the random variables. So now we have to show conditional expectation of xn plus 1, sorry, zn plus 1 given this filtration up to fn is equal to zn. Now what is conditional expectation of zn filtration fn? This can be written as conditional expectation of zn plus xn plus 1 up to given fn, right? So zn plus 1 can be written as zn plus xn plus 1, right? Now conditional if you break it, zn fn and conditional expectation of xn plus 1 given the filtration fn. Now zn is fn measurable, so from the property of conditional expectation you can simply write, you can take it out as zn, and now xn is independent of fn, right? So xn plus 1 independent of this sigma algebra up to fn, so this will be unconditional expectation of xn plus 1, right, according to the property of conditional expectation. Now this is given as 0, so simply, sorry, this is zn. So we have shown this is Martingale. Now in the next problem we will see what is the under which condition the opposite of this problem also holds.